Hello everyone, thanks for coming. And this week we are going to do a final review of what we have learned in this quarter's course, Long-Term Actuarial Mathematics. We learned 4 chapters, and the first chapter is the multiple state models. The typical models are the two-state model represented by the accidental death model. We had 2 levels of payments. The disability model, which is a 3-state model, so the insured life can go from healthy to disabled and then go to death, and directly from healthy to death. Also has a 4-state life joint life model. Those are the representative models in this chapter. Next, we discuss the transition probability. We have T, Px bar II, which is the probability of staying in the state I for at least the time t, as well as Tpxij, which is the transition probability from state I to state j within the time interval t. In order to evaluate the quantity Tpxij, we need the Kolmogorov forward equations. Usually it is done by numerical integration, but in special cases we can also evaluate the transition probability by hand. Then we need to calculate the premiums for the multiple state model insurances, where the insurance can be paid in multiple different ways. Then we need to calculate the present value of the annuity as a result of the transition from I to j, small a, as well as the capital A. This is the present value of the sum to be paid after the transition from I to j happens. Finally, we learned the policy values. The policy values are usually different when the insured life is at different states. For the annual case, we often use the recurrence formula to calculate next year's policy value given the last year's policy value, as well as the premium and the expected amount to be paid. The next chapter is pension mathematics. It is a special case of the multiple state model. First, we learned the salary scale, from which we can estimate an employee's future salary given its current salary and the growth in the salary. We also have the defined contribution and defined benefit plans. The defined contribution is that the contribution from the employer and from the employee is definite, and the defined benefit plan is that the retirement benefit is defined after several years of service. Then we have the service table. It can help us estimate the total number of days withdrawal from labor, as well as the disability and the other values in the pension mathematics calculation. So typically we have the several states: in service state, disability, death, in work, withdrawal labor, as well as age retirement. We also learn how to evaluate benefits, especially how to evaluate benefits after an early withdrawal of labor. Usually, it is accompanied by a cost of living adjustment when the accumulated benefit before withdrawal of labor is applied to pay for the benefits after retirement. Finally, we have the funding plans. It is usually paid by both the employer and the employee. Also, it is composed of a reserve that is stored to pay for the employee's retirement benefit. It is similar to the policy value for the multiple states model chapter. Next, we learned some probability theories that we shall commonly use, often used in the actuarial non-term actuarial mathematics. First, we learned the continuous random variable models. It is usually used to model the total amount to be claimed within one for one claim. We learn how to create new distributions from a known distribution. We have multiplication where y equals to theta x, x is known, power y equals to x to the power 1 over r, exponentiation x equals to e to the power x, mixing where we have several distributions and then we mix them together, slicing where we also have several distributions and the probability density function of the unknown variable can take one of those distributions when the variable x is in different intervals. We also have some more general transformation, and the multiplication power and the exponentiation are all special cases of the general transform where y just equals to g x. X is known, g is a general function and is also assumed to be known. Two parametric families play very important role in our actuarial mathematics: the transformed beta family and the transformed or inverse transformed gamma family. Finally, we also have the linear exponential family. F of x and theta equals to px e to the power rx over q theta. So r is also a function of theta, so it can be seen as a conditional probability of x conditioned on theta. However, if we marginalize over theta given the distribution of theta, then we can obtain the unconditional distribution of x. Finally, we learned discrete distribution. It is also often used to model the number of claims within a time period. First, we know the probability generating functions and moment generating functions, which can characterize the features of a discrete distributed random variable. Then we learned the Poisson distribution. It is often used to model like the number of claims made within a given time interval. Finally, we learned the binomial class. We have the binomial distribution, which is the number of successful experiments if we carried out like an independent identically distributed experiment. We also have the negative binomial distribution, so it is the total number of trials that we have completed when we reached R values. In general, we have the AB0 class. So it is for the probability of a discrete distribution where the non-negative random variable can only take integer values, and the probability that it takes the value k is denoted by pk. Pk over pk minus 1 equals to a plus b over k. We also have the zero truncation version of this AB0 class. It is also usually denoted by AB1 class. In that class, P0 can be arbitrarily chosen from 0 to 1, and the summation from Pi to P infinity is 1 minus P0. And Pk over Pk minus 1 is A plus B over K, where K is larger or equal than 2, not 1. Thanks for listening.